Audio and video, everything okay? Okay. So hi Pranav, hi Akash, hi Sagar, hi Kumar Gaurav, hi Achan. Okay. Right, guys. So yes. So we're going to start with vacutainer. So vacutainer is one of the question which is very, very high pragati. So vacutainer is a very important question which is asked both in your entrance examination as well as in your second year practical examinations. And it is one of the questions that everybody should be very, very clear about. Okay. And there should be no doubt on that. Okay. So remember, vacutainers means they are nothing but they are now the tubes that we use for collection of the blood, and they are sealed under vacuum, so you don't have to pull anything. Okay, so therefore we can directly take the sample in them. So that's the beauty of vacutainers. So now we always have, so we can have anticoagulant in the vacutainer, or we can have an anticoagulant without a anticoagulant. So what is the difference in this? So understand the basic difference. Whenever we have an anticoagulant which is there in a vacutainer, so what will happen? It will not allow the blood to clot. That's number one. Blood will not clot. Okay. So when blood will not clot, what will you do is, so you will centrifuge this blood. And when you centrifuge this blood, obviously, you know that we'll get three layers now. We'll get your RBCs here, Buffy coat, and the top one will be your plasma. So this plasma is basically used for various testing. Okay. So the importance of the anticoagulant in the vacutainer is to get a plasma. Okay. So that plasma is used for various tests. Understood? Now, when there is no anticoagulant in a vacutainer, so whenever there is no anticoagulant, okay, so what will happen? The blood will clot. When the blood will clot, what will happen? Whatever will be separated will be serum. Okay, so this will be serum. So now this serum will be used for different tests. You understand? So simple question to anybody is that whenever I'm saying the word plasma, it means that it has a vacutainer which has an anticoagulant. When I'm saying serum, that means that that is a vacutainer which does not have an anticoagulant. Okay, so that should be very clear. Now, let's come to one more point. So how are the anticoagulants defined? So anticoagulants are defined on the basis of how fast they are reversible. Okay, how fast you can reverse them. That means, so let's say trisodium citrate. Okay, so citrate is a very fragile anticoagulant. It could be quickly reversed with calcium. So as soon as you put calcium, the anticoagulant effect finishes and the blood starts clotting. Okay, so that is citrate. So that means if I want to test the coagulation studies, citrate should be my preferred anticoagulant because it's a fragile one. As soon as I add calcium, the effect is gone and blood will start clotting. Whereas EDTA is a very powerful anticoagulant. It cannot be reversed by anything. That means EDTA can never be used for coagulation studies. Okay, because it cannot be reversed. So when one substance which can never be reversed, we cannot use it for coagulation. Understood? So that also goes for a logic. Okay, so that also goes for a logic, a very important logic, that is, whenever we want to follow in which order I should take the sample, the most fragile anticoagulant should come first. Okay, citrate should come first and EDTA should come last. Why? Because if there is any contamination, what is going to happen is, if the citrate while gets contaminated by EDTA by chance, so what will happen? Your blood will never clot and you will misdiagnose the patient as hemophilia or something like that. Why? Because blood to clot in urine. So understood. So that is why we do not want EDTA to come first. So EDTA is kept at the last and citrate is kept at the first. That should be the first basic logic. Then you should not confuse on that point. Understood? So these are first few logics that you understand before we go into vacutainers. Okay, understood. Now, once you're clear with this, now let's come to the first and the most strong anticoagulant, that is EDTA. So as I told you, EDTA is a very, very powerful anticoagulant and it cannot be reversed by anything. So this is ethylene diamine tetraacidic acid. So this is basically kept in a lavender topped vacutainer, a very strong color, lavender color. Lavender, the second alphabet of the lavender is E, so it has EDTA. Which EDTA? So we always use dipotassium EDTA. Why dipotassium? Because this is because tripotassium is liquid. So if you use tripotassium, it will alter the concentration. Okay, so that is why we always use dipotassium EDTA. That's very, very important. And how much EDTA is present in it? Approximately 1.5 milligram per ml. Okay, now which tests are done in this EDTA vacutainer? Please remember CPC, peripheral smear, ESR by Winthrop. So Winthrop ends with E. So E for E, that is EDTA. Then reticulocyte count, red cell folate, whenever you want to do, you do it in EDTA. HbA1c estimation and hemoglobin HPLC. So these are some tests which are done with EDTA. So this should be clear in your mind whenever you are asked. Okay. So this is the tests which are done in EDTA. So HbA1c was your INI-CT question this time. Okay. So that everybody should be very, very clear. Now, once we are clear with this, now let's come to variations of this lavender top vacutainer. So, when we were giving sample for EDTA to a patient, he was taking the same sample to the blood bank also. So they said, ki, theek hai, we will keep it as an EDTA vacutainer only, but we will change the color for blood bank. That is why whenever we are using dipotassium EDTA for blood bank purposes, the color becomes pink. The color becomes pink. So pink color vacutainer is for blood banking, and it also an EDTA vacutainer, dipotassium EDTA vacutainer. The only thing is this is used for blood banking. So remember which tests are done in this. Whenever you want to do blood grouping and save, what do you mean by blood grouping and save? So tomorrow I have, let's say I have a hysterectomy surgery. I want blood for my patient. So what will I do? I will want the blood group to be done and the bag to be saved. So this is called group and save. For that, I use this EDTA vacutainer. Cross matching. I want to do cross matching. I will send EDTA vacutainer. Direct Coombs test. I want to do direct Coombs test. I will use EDTA vacutainer. Okay, so these are the simple tests which we do on pink top vacutainer. That should be very clear. And this is simple EDTA vacutainer just used for blood banking purposes. Now, once we are very clear with this, let's come to another modification of EDTA vacutainer. So EDTA vacutainer with a gel separator, okay, with a special gel separator. So this is called pearly white tube, and it is basically plasma preparation. It has a gel separator, so the plasma is prepared very nicely. So this is called as pearly white plasma preparation tube. Everything is in P. Pearly white plasma preparation tube. So this is used for test with P only. That is why it is used for PCR testing. So for PCR also we use EDTA vacutainer only. But what is the uniqueness is we use it in a pearly white top. Okay, we use it in a pearly white top. Okay, so what is the uniqueness? It has a gel separator, so it's a plasma preparation tube. So this is for PCR. It's also EDTA. Okay. Now let's come to one more variation of EDTA, which is recently done. So this is your gray topped vacutainer. This gray topped vacutainer is basically gray because it has a very special molecule in it. It is sodium fluoride. So sodium fluoride is added to inhibit enolase. So enolase enzyme is important in the glycolysis. So to inhibit enolase, this is there. This is what is the anticoagulant in it? So earlier it was potassium oxalate. Okay, earlier it was potassium oxalate, but now they have added EDTA itself. So now this gray top tube is also having EDTA. Okay, so if you look at the tube, if you have in your hospital, please see here, it will be written EDTA with sodium fluoride. Okay, so EDTA with sodium fluoride is basically your gray top vacutainer. Earlier it was potassium oxalate. Please remember what is the uniqueness of this? Uniqueness of this is that if you keep this tube, okay, at 25 degree, the sample remains viable for 24 hours. If you keep it in 4 degrees centigrade, the sample is viable for 48 hours. Achha. Now, what is the rule for EDTA? So E is like this. So any sample of EDTA, once you have taken, make it, how many times you should shake it? You have to invert it 8 to 10 times. So you should invert this tube 8 to 10 times. So that's the uniqueness of this, you have to remember. Okay, invert it 8 to 10 times. Okay, so that is the uniqueness of any EDTA tube. How many times you should invert it? 8 to 10 times. Okay, so that's your EDTA tubes that we have covered. So what are the EDTA tubes? The general lavender top tube, the pink top tube for blood banking, the white pearly white tube for PCR, and gray top tube for glucose estimation. Is everybody clear for this? Okay, so that is your EDTA vacutainers. Now, once we are clear with EDTA vacutainer, this was the question that I had given you in the quiz yesterday. So which anticoagulant is used in the gray topped vacutainer? So I purposely didn't give sodium oxalate because sodium oxalate is also correct answer. In earlier times, we used to have sodium oxalate with sodium chloride. Okay, but nowadays we have EDTA with sodium chloride. So that is one thing that you have to know and update yourself. Okay, so the answer to this is A. Now let's come to the second important vacutainer, that is heparin. So the heparin, remember, we have two types of heparin salts which we can use: sodium heparin or lithium heparin. Okay, so whenever we are talking about this heparin tube, where all we can use it, so there's a very simple rule for this. Okay, so this rule you have to remember that basically this is used for H, so GI, hogi. Okay, so this is for hogi. Okay, say in Hindi say hogi, heparin hogi. Okay, this is hogi. Okay, and what is hogi? Heparin is used for O, very important test, osmotic fragility test. It is used for osmotic fragility test. G, very important, gas analysis, blood gas analysis. I, very important, immunophenotyping, flow cytometry. Remember, for flow cytometry, we can use either EDTA or we can use heparin. The difference is the validity for EDTA is 24 hours. The validity in heparin is 48 hours. So sample remains viable for 24 hours in EDTA and 48 hours in heparin. So that is hogi, you have to remember. Apart from that, you have to remember fish and cytogenetics ke liye bhi we can use heparin. So which technique? So PCR ke liye what are we using? EDTA. So remember, there was a question I remember asked, and that is asked in your NEET PG exam. So which anticoagulant can never be used for PCR? It is heparin. So heparin can never be used for PCR. Which anticoagulant is particularly used for fish? Okay, so remember, fish always ends with H. Okay, so that is heparin. So fish ke liye kaun sa anticoagulant hota hai? Heparin. Fish loves heparin. Okay, so fish is done with heparin. Now, what is it? Now, what is the difference between sodium salt and lithium salt? See, sodium salt, we particularly use sodium salt whenever we have to estimate the lithium levels. So whenever you want to estimate the lithium levels, remember this lithium levels are done in sodium heparin. That's a very, very important point. Okay. Ammonia levels can be tested in both sodium and lithium heparin, but lithium levels are only tested in sodium heparin. Apart from that, lithium heparin is particularly used for testing electrolytes. And this was your INICT question also this time, right? So for electrolytes, the preferred anticoagulant is lithium. Now, why is this light green? Okay. So remember that lithium heparin. So I'm just highlighting. See here, we have three vacutainers here. So this is your sodium heparin and lithium heparin. Both can be dark green, but we also have a light green color lithium heparin. Why so? Because this light green color lithium heparin has again a gel separator. So whenever we have a light green color heparin vacutainer, it has a gel separator. It has a gel separator. So that is what it is used to. Point to be noted here, guys, lithium heparin is a preferred anticoagulant for electrolytes. Okay, that's the question that was asked in your INICT exam, right? So that is what you should be very clear with. Okay, understood about heparin? So osmotic fragility, blood gas analysis, flow cytometry can be done either on EDTA or heparin, and for fish, heparin is the preferred anticoagulant. Okay, so that's what you have to remember. So why is light green color? What is the difference between light green and dark green color? So light green has a gel separator and it is lithium heparin, okay, which you should be remembering. Okay, now once heparin is clear to everyone, now we should know trisodium citrate. So C for C, Trisodium citrate, I told you, it is the anticoagulant which is reversed with calcium. So it's preferred anticoagulant for coagulation studies. Okay. So C for coagulation, C for citrate. So any test like PT, APTT, D-dimer, if you want to do, you have to use trisodium citrate. Okay. So there was a question which was asked, INR के लिए कौन सा anticoagulant use करोगे? It is trisodium citrate. Now, there are two concentrations again for trisodium citrate. It is 3.2 and 3.8. The difference is for coagulation studies, we always use 3.2, okay, gram per deciliter. And the ratio that we used is always 1:9. That is 1 volume of anticoagulant to 9 volume of blood. Remember, this trisodium citrate vial has to be filled 90%, okay, to say that it is accurately filled. Okay. If it is less than 90% filled, we don't consider this tube as adequately filled, and we cannot do testing. It has to be filled 90%. Now, apart from that, what is the difference between 3.8%? So 3.8% was actually used for ESR estimation. So whenever you have to do ESR estimation by Westergrens, okay, by Westergrens, it is done at 3.8 gram per deciliter. And then we use the ratio of 1:4. That is 1 volume of anticoagulant to 4 volumes of blood. So there was a lot of confusion going on. So they changed the color itself. So this blue, okay. So blue B, what is closer to the B? C alphabet, no? So blue color is for citrate, trisodium citrate, and it is for coagulation. At 3.2, blue is the second alphabet. So 2, okay, 3.2 is basically for blue. Okay, remember that. Now 3.8, 8, okay, is like, you write like 8 like this. So 8 is basically black. Okay. So B is like 8, isn't it? So it is for black topped vacutainer. And this is for your ESR. Remember, this is how the tube actually looks like. So this is your ESR tube. It has trisodium citrate at the concentration of 3.8%. And this is done for ESR by Westergren's method. So this is one tube that everybody should be very clear with. Okay. Now, this was the question that I gave you in the quiz yesterday. Which anticoagulant is there in a black-topped vacutainer? So it is trisodium citrate that you should remember. Apart from that, which anticoagulant is used in osmotic fragility testing? You should remember it is heparin, which is used for osmotic fragility. So please don't do these questions wrong now after this session at least. Okay, everybody try to remember it well. Now, coming to the tube which does not have any anticoagulant now, this is serum tubes. Okay. So first tube that we come is a red topped vacutainer. So this vacutainer has the clot activator. And this was again a question which many students do it wrong again and again and again. It has a clot activator so that it helps in making the clot quickly. So once the blood is clotted, what remains is the serum. So this serum is used for basic chemistry, liver function test, kidney function test, okay? For serology, in blood banking, if you have to do hepatitis B testing, okay, HIV testing, okay, so that is done in serum vial. Immunohematology, indirect Coombs test, if you want to do, and you want to pick up the antibodies which are there in the serum, you can use red top vacutainer. So this is your serum vacutainer that you should be remembering. Okay. So please remember, this is a serum vacutainer. Now, what is the problem with this vacutainer is it has a clot activator. It forms the clot, but can you see the clot and the serum are very close enough. So suppose if you're transporting the sample from one lab to the another lab, what is going to happen? These red cells can get hemolyzed. And when they get hemolyzed, it can immediately mix into the serum. So आपका sample खराब हो जाता था. So therefore they came up with a solution called as golden top tube. Okay, so this was the golden top tube, and it has again gel separator. It has a gel separator. So that is why this is called serum separator tube. Okay, so this is also called as serum separator tube. Please remember, they can give you a question like that. Do you remember what is plasma preparation tube? PPT. That was for PCR. Okay, so pearly white plasma preparation tube, that was PPT. So it had EDTA as a vacutainer, so it was making plasma. So it was plasma preparation tube which was used for PCR. This is serum separated tube. You understand that there is no anticoagulant, it forms serum. So it's a serum separator tube. It has the clot activator and it has the gel separator. Now what happens here, when the blood clots, the red cells come down and the sorry guys, one second. Okay, so the red cells come down and the serum come above, serum comes on the top. So now the problem of hemolysis is much less. Okay, so that is the beauty of this, and the samples can be transported. So one, it clots, it takes less time to clot, it takes less time to clot, it clots in 20 to 30 minutes itself. And second, it the problem of hemolysis is less. So you do all the biochemistry, vitamin B12, folic acid, everything you can do, liver function test. Now, suppose if lithium heparin is not given in the option, so which vacutainer can be used for electrolytes, and lithium heparin is not given in the option, then you can do electrolytes even in the serum tube, that is golden top tube. You can do electrolytes in this also. Okay, so remember that point always, because that was a question or a doubt which many students had. So let that be clear. If lithium heparin is in the option, that's a preferred anticoagulant. If that is not in the option, then golden top serum separator tube should be the answer. Now, to further understand this concept better, we have a yellow topped vacutainer. This is not golden top. This is yellow topped vacutainer. Remember, it has ACD, that is acid citrate dextrose. Along with it contains sodium polyethyl sulfonate. Okay, sodium polyethanol sulfonate. This is an anticoagulant which was actually used for blood culture bottles, and we can use it in for HLA phenotyping. So HLA phenotyping ke liye we can use this yellow topped vacutainer. It contains ACD and SPS. Okay, sodium polyethyl sulfonate. Okay, so that is your yellow topped vacutainer, which you should not have any doubt on. Okay. So now once we're clear with this, always remember what is the order of draw, because that's a question that they ask you always. This will come in exam. Invariably, it will come in exam. So what is the order of draw? सबसे पहले तो culture लेना है. There's no doubt about that. Then first reversible one you have to take, because you don't want any contamination in that case. So you take citrate, and after that you take serum, so that you can let the blood to clot. Okay, because it takes up, if you're using a red top vacutainer, it will take 60 minutes. If you're taking a golden top vacutainer, it is going to take 20 to 30 minutes. So remember, CCS should be the first thing. Uske baad, the last one that you should take should be EDTA. And if you add one more substance in EDTA, it becomes more robust. That is for glycolytic inhibitor, fluoride. So EDTA with fluoride. So EDTA ones are the last one. Okay, so EF are the last one. Okay, so EDTA and fluoride are the last one. So what comes in between? H. Heparin comes in between. So remember the simple code. You don't have to mug it up, or you don't have to confuse. Remember the simple thing: CCS, HEF. So always use culture first, then citrates सबसे पहले ले लो. Then you have to allow the blood to clot, serum. Okay, then heparin will come just in between, and the last one will be EDTA and fluorides. These are the last one. So that is what you have to remember. Always remember, citrates are blue topped vacutainer, serums are red and golden top vacutainer, heparin is green top vacutainer, EDTA is lavender top vacutainer, and fluoride is gray top vacutainer. So colors should be very clear to everyone. Now, these are the simple anticoagulants which are there, but remember there are anticoagulants in the blood banking also, which you should be very clear. So these are the anticoagulants in the blood banking. Remember simple one, ACD, that is acid citrate dextrose, which was the first anticoagulant to be used. It had life of only 21 days. Then we came with CPD, that is citrate phosphate dextrose, which gave a life of 28 days. Then the most commonly used anticoagulant in today's time is CPDA, that is citrate phosphate dextrose and adenine, which gives you a life of 35 days. And the last and the most robust one, which has been recently added. So Sagum is added along with CPDA. CPDA to hota hi. Along with that, we add Sagum. Sagum has mannitol. It is saline, adenine, glucose, and mannitol. So it maintains the pressure and it gives a life of 42 days. It extends the life to 42 days. So Sagum is just a additive. It is just a additive. So somebody asks you which is the most common anticoagulant used in today's time in blood banking, the answer should be CPDA. Okay. So which is the most common adsol or additive which is used in blood banking nowadays? It is Sagum. So do not confuse on these 2 points. Okay, you should be very clear. Now here you should remember what are the ingredients. So if you look at the dextrose, so start with CPD only. C, citrate. Citrate is very important anticoagulant. Okay, so that is it. Phosphate maintains P for pH. Dextrose, it supports ATP by providing glucose. And adenine is synthesizing ATP. It is synthesizing ATP. So these are the uses of the anticoagulant solution, which everybody should be super clear. Okay, so that should be your vacutainers and anticoagulants, which should be very, very clear. So if they give you this in exam, okay, which is the anticoagulant which is used for this tube? So what is this test that is shown? So this is Westergren pipette. Remember, Westergren is a pipette. It is open from both ends. It is a 30 centimeter long tube. It has marking only on one side because it is only used for ESR. What is ESR? Erythrocyte sedimentation rate. That is, you have to see the fall of RBC. Okay, so this is ESR, and ESR by Westergren. Which anticoagulant is present in it? Trisodium citrate. Okay, so trisodium citrate is present in it, which you should be very clear. Now I changed the question. Which anticoagulant is present in this tube? So when you see, look at this tube, you know, there are marking from both the side. So this is a 11 centimeter tube with marking from top to bottom and up to down. So this is your Vintrobe's tube. Okay, so why does it has marking from both sides? Because fall agar aapko dekhna hai, fall of red cells, if you have to see, that is ESR. Apart from that, because it's a smaller tube, you can centrifuge it. And you already know, whenever we centrifuge the tube with a anticoagulant, 3 layers are formed: RBCs, buffy coat, and the plasma. So the packing of the red cells can be seen. How much the red cells are packing, that can also be seen. And that gives you PCV. So you can see PCV and ESR both together in which tube? Vintrobe's tube, because it has marking from both the side. So why can you do this? Because it's a tube, so it can be centrifuged, and it's a smaller tube. It's an 11 centimeter tube. So yes, we can see both ESR and PCV in Vintrobe's. And what is the anticoagulant? It ends with E. So the anticoagulant that we use for Vintrobe's tube is EDTA. Okay, so what is the anticoagulant that we use here? It is EDTA. So that should be very, very clear to everyone. So that is about VACUTAINERS and the anticoagulants, guys. So it was a small session. So guys, please remember, this question will invariably come in your exam. Please revise this well. You should know this concept well, because you should not do this wrong. Okay, so with that, we will end today's session. And do let me know if you like these sessions. We can have small such sessions whenever I'm free. So do let me know, and do let me know your feedback. With that, signing off, guys. Bye bye. Happy reading. Right.